Once again, we're on page P7, and we're ready to go. Okay, so when you're thinking about factoring, you can kind of think about it as reversing FOIL for a polynomial. When we multiplied, we would always end up with an answer that would somewhat fit this form. So like x squared minus 5x minus 6. Okay, so when we FOILed, we would end up somewhere in this area. We always had three terms, usually an x squared, a single x associated with a coefficient, and then a constant. When you're talking about factoring, you're talking about breaking this into its individual parts. Okay, so you're working FOIL backwards. Okay, and this is what's known as a trinomial. It's a method of polynomials, but where we're going to start is with binomials that share a greatest common factor. So the first example they give us is 4a squared plus 8a. Okay, and factoring is an essential part of upper level mathematics. I actually just had to cover it with my pre-calc kids because we were talking about using the quadratic formula and finding roots of a parabola. So when you're given a binomial term like this and they say factor, okay, what we're trying to do is we're trying to find the greatest common factor. And then we're going to reverse the distributive property. Okay? So when you're trying to find the greatest common factor, you want to ask yourself, is there a number and variable that can go into both of these terms? Okay? And the first one that probably pops into your head is a 2. Because 2 times 2 is 4, and 2 times 4 is 8. So 2 goes into both of those. So when we're reversing the distributive property, and we were factoring out a 2 here, you can see that we'd be left with 2a squared plus 4a. Okay, and you can always check yourself by rerunning the distributive property. The distributive property by nature says that anything on the outside that's multiplied by the parentheses should be multiplied by both terms to get your final answer. So 2 times 2a squared would give you 4a squared, and 2 times a positive 4a would give you 8a. So in theory, 2 would be a factor, but it's not the greatest common factor. Okay, and the reason being is at this level, you can see our coefficients of 2a squared and 4a, they also share a factor. So we would have to repeat this property again, which would bring out another 2. So on the outside, we'd have 2 times 2, which would give us on the inside a squared plus a, or 2a. So now we're getting closer, okay, because our coefficients do not share a common factor. A 1 and a 2, they're what's known as prime. Okay, so the only number that can really be multiplied to equal either one of those numbers is itself and 1. This is the whole reason why we want to try to find the greatest common factor. But if you're looking at it, we do still have a common variable. Okay, the first term has 2 a's, and the second term has a single a. So when we're factoring out the greatest common factor, we would also bring the variable with us. So on the third level, we would have 2 times 2 times a, and on the inside we would have a plus 2. Okay, so this is its simplified or most simple form. It's the area that we want to go. But as you can see, that took us a lot of work to get there because we didn't take the greatest common factor. This, in a sense, would be the correct answer. On the outside, we're going to have 4a. And on the inside, we're going to have a plus 2. Okay? And if we were to graph this, this would be a parabola. And we would have a 0 at 4a, and we would have a 0 at a plus 2, talking about x-intercepts. But that's way down the road. That's why factoring is important, is to help you quickly find the roots of an equation. Okay? So if we're going to look at another one, another binomial term, and we want to factor out the greatest common factor. So we're given 5x squared plus 25. Okay, so we want to ask ourselves, and we want to look at the coefficients first. What is the greatest number that'll be multiplied to equal 5 and 25? And the answer to that would just be 5. So we know we want to bring a 5 out. So 5x squared divided by 5 give you x squared, and 25 divided by 5 would be 5. Okay, at this level, you can see I didn't take the variable to the outside. That is because both of the terms that are in the parentheses do not share a common variable. You have an x squared, and you have a 25. So this, even though I didn't bring the variable to the outside, this is its simplest form. 5 times the quantity of x squared plus 5. Okay, and once again, this is how you factor a binomial term. So we are looking at trying to bring out the greatest common factor between both of our, or that's contained within the parentheses, so we can put it to its outside and make it in its simplest form. One more, because the book and other areas try to confuse you. We'll go 25x squared y plus 125x y squared. Okay, and in this case, we have a number that can go into both, and we have variables that are duplicated on both terms. So in this instance, we're going to take out a number and both variables. Okay, so think to yourself, what is the greatest number that goes into both coefficients and can be multiplied even? So off the top of my head, I can think of 25. It'll be multiplied to equal 25 as 1. And then 125 times 20 divided by 25 is 5. Okay, so I know I want to take a 25 out. Looking greatest common factor. But now we have to talk about variables. You can see our first term has x squared y, and our second term has x y squared. So they're not the same, but they share a common variable. Okay, so in this case, we can take out a single x and a single y because both terms share the variable x and y. We can't take out x squared because 125 just has a single x. And we can't take out y squared because 25 just has a single y. If they both had squared, we'd be able to bring that to the outside, but since they don't, we can only take out 1. So we ask ourselves, what is 25x squared y divided by 25xy? And the answer to that is going to just be x. Okay, and that's because 25 is going to cancel out that, and that's going to be just 1. Our x is going to take away 1x, and the y comes with it. So we're just left with x, or 1x, because 25 times 1 is equal to 25. Looking at our second term, we have 125x y squared, and we already know we want to factor out 25xy. So 125 divided by 25 is 5. We're already bringing out an x, so that stays, and then we would just have y. And like I said, the way to verify that you're doing it correctly is if you do, or if you perform the distributive period property, you should end up back where you started. So 25xy times x is going to give you 25x squared y, and 25xy times 5y is going to give you 125xy squared. And I compare that to where I started. That checks out. So this is its simplest form. And the nice thing is you can always double check yourself. If you feel like you might have got it wrong, repeat the distributive period property. Okay? So that's how you factor a binomial term. Think find the greatest common factor and reverse the distributive property. So in other words, you're dividing. But now, the more popular ones that they ask you are having to deal with trinomials. Okay, and when I factor trinomials, I teach the box method. The box method is really nice because it makes your life very simple. It has multiple built-in ways to check yourself. Ms. Hartzell, don't look at me like that, okay? But you got to remember there's a million different ways to skin a cat. So it's just the way that I feel most comfortable with, and that I'm going to share with you. So the example that we're going to be working on is example 2 from page P7. And if you take a look at the seesaw activity for the lecture, you have a PDF attached that is a little cheat sheet for the box method. Okay, and it looks like this. Okay, and first thing when we're considering the box method of factoring, we must factor out the GCF, or the greatest common factor, out of the polynomial first if it's possible. Okay, and the second thing that we can't have is a negative a value. Okay, and if you're looking, we're going to be dealing with terms ax squared plus bx plus c. Okay, but this is the document I'm going to be working off of, so you can feel free to do that. Follow along and use the steps that way. But we are also going to be doing example 2, and I'm going to walk you through the box method with that. So example 2, letter A, it gives us the equation x squared plus 5x plus 6. Okay, with the coefficient associated with the x squared is a, next one is b, and our constant is always referred to as c. Okay, to help you. Trinomial, they always fit this pattern. A is associated with x squared, b is associated with our single x variable, and c is our constant or our y-intercept if we were graphing this. Okay, and it asks us to factor. So using the box method, the first thing we have to ask ourselves, is there a number that can be multiplied to equal 5 and 6? Okay, 6, the only way you can multiply to get that is 1 and 6 and 2 and 3. 5 is a prime number, so its only factors are 1 and 5. So there is no GCF. The GCF does not exist in this case. Okay? If it did, we would take it at that point and factor it out. The next thing we got to check is make sure that we have a positive a value. Since it doesn't say negative x squared, we have a positive a value. So a is positive. So we can put a check mark. We've passed our two conditions, and now we know we can use the box method, okay? And the first step to the box method is we're going to draw a box. A nice, pretty box. You know, sure it has all 90-degree angles, beautiful cross, dividing it into 4 quadrants. Okay, and then the second step, we're going to put our value of a into the top left corner, inclusive of variables. So that is, since we don't have a coefficient, it's assumed to be 1. So all we have to put is x squared. In the bottom right-hand corner, we're going to put our constant of c. Okay, so we fill out the top left and the top and the lower right of our box. The next step is we're going to multiply these two. Okay, x squared times 6 is equal to 6x squared. Okay, what this shows us is we need to think of two numbers that multiply to equal x squared, but also add up to equal our middle term of 5x. Okay, so we're trying to multiply to equal 6x squared. We're trying to add them up to equal 5x. Okay, so in this case, I can think of 2x, and 3x. So 2x times 3x does equal 6x squared, and 2x plus 3x does add up to be 5x, so it checks both of our requirements. Okay? And that's just in your first 3 steps. Once again, I filled in A in the top left, C in the bottom right. I multiplied these two together to get 6x squared. So I needed to find 2 factors that multiplied to equal 6x squared that added up to equal 5x, because 5x is our middle term. Okay, so we use all of our terms. Okay, at this point, since I've found what I think my factors are, I'm going to fill in the rest of my box. And the beautiful thing is, it does not matter where they fall. Okay, I wanted to give myself a little bit more room, but it's okay. So now I have my box completed. Now what we are going to do is we're going to factor out the greatest common factor from row 1 and row 2 that move horizontal. Rows move horizontal. And we're going to factor out the greatest common factor from column 1 and column 2, going up and down. Okay, so we'll work column 1 first. Column 1's here. It's going down. You can see I have the terms x squared and 3x. The greatest common factor between those is x, right? Or a 1x. So we'll put x right there. Looking as we go down here, C2, we have 2x and a positive 6. So at this point, we're going to factor out a 2. Okay, I have a chat. I'll try, Ashlyn. I'll try. She was asking if I could write bigger or clearer. Unfortunately, I kind of write like a child, so I'll do my best. Hopefully, we'll get through this one, and then I'll try to blow it up as big as possible in the next one. Because we're going to do multiple and multiple of these boxes, but we'll get it done. We'll get it done. Okay, so where I'm at, I've factored out the greatest common factor of column 1. I've factored out the greatest common factor of column 2. Now it's time to factor out the greatest common factor of row 1. So I have x squared and 2x. Once again, the greatest common factor between those is x. And I can erase some of this, give us a little bit more room. And then I factor out the greatest common factor of row 2, which is the bottom row going left to right. I have a 3 3x, and a 6. The only thing I can factor out there is a 3 because the 6 does not have an x, or else I'd be able to factor out 3x. Okay, now at this point, another beneficial thing is you don't have to assign positives or negatives yet. I always do that after I check myself. So with all of my terms being positive, it's safe to assume that it is going to be positive. But if I were to multiply x times x, they're going to multiply to equal x squared. Okay, you follow that x all the way across, follow that x up. Where they meet is where they should multiply to equal. So x times x is equal to x squared. X times 2 is equal to 2x. X times 3 is equal to 3x. And then 3 times 2 is equal to 6. So this passes my box. So I know, or I assume, that my factors are x plus 2 and x plus 3. So once again, to check yourself, you can always multiply them back together. Since these are two binomial terms, we'll have to multiply them with FOIL. So x times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. If I combine my like terms, you can see that I end up back where I started with x squared plus 5x plus 6. Okay, so that's the first version of your box method to factoring. We're off to example 2, letter B. Okay. Let's give myself plenty of room. So I'm going to try to blow this thing up. All right, so letter B, we're working with the equation x squared minus 8x plus 12. So x squared plus 8x, or minus 8x plus 12. So the first two things I want to check is I want to make sure that there's no greatest common factor that I can factor out, and that my value for A is positive. So once again, I'm going to examine the coefficients between all of my terms, because that would be the only thing I'm able to factor out. 8 and 12 do share factors, but you can't factor it out because there's a 1 here, right? The only thing we'd be able to factor out is a 1, which is very redundant. Next thing, we want to make sure that we don't have a negative a value. Since it is a positive x squared, we know A is positive, so we can begin the box. That big enough? Brock, you're on the Zoom call, right? Can you read it from your computer? All right, yeah. So I have my box drawn. Now I want to put the value for A, inclusive of variables, into the top right. And I want to put my value for C, inclusive of variables, into the bottom right. Top left and bottom right, sorry. A goes top left, C goes bottom right. Now, I'm going to multiply A times C, and I'm going to get 12x squared, okay? And my value for B, what they have to add up to, is a negative 8x. Okay? So now it's time to think, what two terms are going to multiply to equal a positive 12x squared? They're going to add up to equal a negative 8x. And the two that I can think of are a negative 6x and a negative 2x. Okay, if we multiply negative 6x times negative 2x, it does equal a positive 12x squared. And then negative 6x plus a negative 2x does equal a negative 8x. So at this point, I'm pretty sure I picked out my complementing terms, and I can fill out my box. Negative 6x and a negative 2x. Once again, for these two squares, it does not matter which term you put in because we are factoring out the greatest common factor from this point. Okay, and you will get the same answer. So here's row 1, here's row 2, here's column 1, here's column 2. Once again, rows run horizontal, columns run up and down. Okay, so working with column 1, and it doesn't matter which one you start on, you're going to factor out the greatest common factor of all 4. Okay, it's just the habit that I start with the columns and work left to right. So looking at column 1, I have an x squared and a negative 2x. So the only thing I can factor out there is an x. Okay, looking at column 2, I have a negative 6x and a 12. I can factor out a 6. I can't bring the x because my 12 does not have it. Looking at row 1, x squared and a negative 6. I can only factor out an x. And the negative 2x and 12, the only thing that I can factor out is a 2. Okay? One of the keys to factoring, and one of the reasons that we factor out the negative, if it's negative here, is so that our x values are always going to be positive. Okay? When we're factoring, we never want to have a negative x plus 6. Right? X's will always be positive. And if we check ourselves, x times x is x squared. Okay? Now, if we check this, x times 2 is a positive 2x, but we needed to have a negative. So that makes this x minus 2 as our binomial on the side. Okay? Going here, 6 times x is positive 6x. We always want to have a positive x value. So we have a negative 6. And now we can really compare to make sure we've done it right. Negative 2 times negative 6 does equal 12. Negative 6 times x is a negative 6x. X times a negative 2 is a negative 2x. X times x does equal x squared. So we can say with probably about 95% positivity that our binomials on this equation are x minus 2 and x minus 6. But once again, if you're ever in doubt, check it using FOIL. So x times x is x squared. X times negative 6 is a negative 6x. Negative 2 times x is a negative 2x. Negative 2 times a negative 6 is a positive 12. We combine our like terms in the middle, and it shows that we have x squared minus 8x plus 12. Okay, so we can say our factors are correct, and that would be our answer for example 2, letter B. On to example 2, letter C. And we're going to beat the box method into submission before we confuse you with special projects. Okay, so we have x squared plus 14x minus 15. So we want to check to make sure that we don't have any greatest common factors and that our a value is positive. So 14 and 15 don't share any factors. The only one would be able to factor out is 1, so we're good there. And our a value is positive, so we are good there, and we can proceed to our box. Once again, we take the term a and we put it in the top right. Take our term for C, and why do I keep saying top right? Put our term for A in the top left, and we put our term for C in the bottom right. Top left, bottom right. Remember. Feel like I'm talking a lot. Okay, so the next step, we multiply these two together to get a negative 15x squared. Okay, so we need to find two terms that are going to add up to be a positive 14x that are going to multiply to be a negative 15x squared. Okay, so looking at it, 15, some factors are 3 and 5, but they don't add up to 14. 1 and 15, depending upon how the signs are, those are the ones we're going to want to work with. Okay, so we need to multiply to equal a negative, so we know one of our interior terms has to be negative. Okay, so I'm going to choose a negative 1x and a positive 15x. If I multiply those together, I get a negative 15x squared. And then if I add those together, I do get a positive 14x. So I'm good with a negative 1x and a positive 15x. Okay, so now it's time to factor out the greatest common factors from our rows and columns. So column 1, column 2, row 1, row 2. Once again, columns up and down, rows work horizontally. So row 1, x squared and a negative 1x. Most I can take out is x. Row 2, 15x and 15. The greatest common factor between those is 15. X squared and 15x, x. A negative 1x and a negative 15. The most that I can take out of that is 1. So once again, I don't put my positives or negatives in until I check myself. So x times x, always x squared, and these are 100% always going to be positive. So in order to get a negative 1x, this 1 down here has to be negative. Negative 1 times x is negative 1x. X times 15 is 15x, and a positive 15 times a negative 1 does give me a negative 15. So I'm pretty confident that these are my binomials. And then I will check them with FOIL just to make sure. So I have x squared minus x plus 15x minus 15. Combine my like terms. And I do end up with x squared plus 14x minus 15. So my answer would be x plus 15, x minus 1. Okay, so you can see the box method. It's simple, it's pretty quick, it's pretty easy. And the best thing is it helps you solve when your variable for A is not just 1. Okay, so if we go to page P8, we're going to be working on example 3. With the box method, the beautiful thing is it's the same process. This is just a little bit more difficult problem because the value for A is not just going to be 1. So the equation that they give us is 6x squared plus 7x minus 3. Okay, once again, I want to browse through and make sure that I have no greatest common factor in my trinomial. 6 and 3 share a factor, but 7 does not. So I cannot factor out a greatest common factor because it is not present in all 3 terms. And then I also want to make sure that I do not have a negative value for A. So I am good. I'm ready to begin the box method. So I take my term for A, put it in the top left, take my term for C, and I put it in the bottom right. And then I multiply these two together to get a negative 18x squared. My term for C is a positive 7x. Okay, so now I got to think to myself, what multiplies to be a negative 18 that adds up to be a 7x? So one of the common ones is x, or 1x and 18. X, those ones don't work because they're not going to add up to a 7. What about 3x and 6x? Once again, those can be combined. Those are going to equal 18x squared, but they don't fit the requirements. And then I have a 9x and a 2x. Those are going to multiply to equal 18, and depending upon the signs, it's going to be 7. Okay, but since I'm multiplying to equal a negative 18x, one of these terms has to be negative. So I'm going to choose 9x and a negative 2x. And once these terms are multiplied together, they do equal a negative 18x squared. And 9x plus a negative 2x does equal a positive 7x. So I'm pretty confident that these are my terms. So I'm going to bring them in. Okay, and now at this point, it's time to factor out the greatest common factor from the rows and the columns again. So working row 1, I have 6x squared and a negative 2x, and I want my x value to be positive, so I can factor out a 2x. Working on the bottom, I have 9x and a 3, so I can factor out a 3 there. Working 6x squared and 9x, the greatest factor between those two is 3x. And then negative 2x and a negative 3, I'm going to take out a negative 1 because that is the only factor that shares both between 2 and 3. Once again, they're prime, right? So knowing your primes helps. Now it's time to make sure that when I multiply, they equal together. So 2x times 3x is 6x squared. 2x times a negative 1 is a negative 2x. 3x times 3 is a 9x. And then negative 1 times 3 is negative 3. So these fit. So they are 2x plus 3 and 3x minus 1. Once again, I'm not 100% sure, so I'm going to check them using FOIL. 2x times 3x is 6x squared. 2x times a negative 1 is a negative 2x. 3 times 3x is, why am I drawing a blank? Positive 9x. And 3 times a negative 1 is a negative 3. If I combine my like terms in the middle, I get 6x squared plus 7x minus 3. Okay, so these pass. Those are my factors. Any questions on trinomials using the box method? Step to the side so you guys can see them. Okay. Okay, so now we're off to special products. It's a squared plus. Okay, so we have a couple perfect square trinomials. Okay, so what it means when you have a perfect square trinomial it's when they are factored, they would break down into this form. Okay, but as they're going to be presented to you, and A and B are just variables, okay, they can be almost any number, but this is why it's important to know your squares. So if I were to FOIL these out, A plus B squared is equivalent to A times B times A plus B, or A plus B times A plus B. That's what that means. If I FOIL these out, I have A times A, which equals A squared. I'm going to have AB as a positive. I'm going to have BA as a positive. And then I'm going to have B times B, which equals B squared again. And then if I combine my like terms, you can see that they're going to break down to A squared plus 2AB plus B squared. Okay, and this is the form that it's going to be presented in, because that's the trinomial. And once again, we're trying to figure out the factors. Okay, we're trying to figure out the factors. The good news is the box method will work to handle these. It's just quicker if we can remember these perfect square trinomials. So if I FOIL out the next one, we have A minus B squared. Understand that that's equivalent to A minus B times A minus B. And they are going to equal A squared minus AB minus AB plus B squared. Because two negatives multiplied equal positive. And then once we combine like terms, we're left with A squared minus 2AB plus B squared. Okay, so that's your first one. Those are known as perfect square trinomials. Okay, once again, the form that they'd be given to you in is A squared minus 2AB plus B squared and A squared minus 2AB plus B squared. Okay, that's this one and this one. This is the form that they presented to you. This is the form that they presented to you. Okay, the final one that we have is the difference of squares. Okay, a difference of squares shows up if we have the general form A plus B times A minus B. Okay, if we were to FOIL those out, we'd have A squared resulting from A times A. We'd have a negative AB because A times a negative B. Then we would have a positive AB. And then we would be left with a negative B squared. Once again, because a positive times a negative always yields a negative. If we combine our like terms, you can see A squared, the negative AB, and the positive AB are going to cancel out. We're going to end up with negative B squared. Okay, so those are your perfect square trinomials. So I'm going to give you a couple seconds to write those forms down. If you don't want to write them down, you will eventually, you're going to use them. They're right above example 4 on page P8. Okay, so I'm going to give you a couple minutes to write those down. So, and the key to using these is knowing what your perfect squares are. Okay? So off the top of your head, you should be able to go to at least probably 15 squared would be a good one. So, or if you struggle with them, here are your perfect squares. You have 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. 5 squared is equal to 25. 6 squared is equal to 36. 7 squared is equal to 49. 8 squared is equal to 64. 9 squared is equal to 81. 10 squared is equal to 100. 11 squared is equal to 121. 12 squared is equal to 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. Okay, in order to use these perfect squares, or in order to use these special products and be able to find their factors very quickly, you have to know this information almost ready to go. Okay? And the way you want to approach it is you want to compare your first term versus your last term of the given equation and make sure that they both are perfect squares. If they are not perfect squares, it is not a special product. Okay? If they are special, or if they are perfect squares, there's a chance that you have it. Okay, so the first one that they give us is 4x squared plus 20x plus 25. Okay, so we'd examine the problem and we'd think about it and we'd say, hey, I think this fits one of my special trinomials. Okay, so I'm going to double check. 4 as a coefficient is a perfect square. The square root of 4 is 2, so that could be 2 squared. 25 is a perfect square. Could be 5 squared. Okay, this is the hard one to find, the middle one. And that is because it has to fit the form where 2 would be A, or 2x would be A, and 5 would be B. This term has to equal 2 times A times B. So if we were to check it, we'd have 2 times 2x times B. And if we multiply those together, 2 times 2x is 4x, times 5 is 20x. So this does fit a perfect square trinomial. And if we were paying attention, we know which format it already fits. Okay? The middle term is positive. So, or in our last term is positive as well. Our middle term is positive. So this is going to fit as 2x plus 5 times 2x plus 5. Okay? Or we can present it as 2x plus 5 squared. Okay? And if you doubt it, you can FOIL it back together. 2x times 2x is 4x squared. 2x times 5 is a plus 10x. 5 times 2x is a plus 10x. 5 times 5 is a plus 25. We combine our like terms, we do end up with 4x squared plus 20x plus 25. Okay? And then your last example is of the difference of squares. Okay? Once again, it all centers around knowing these. Okay? If you don't know these, it's very difficult to use the perfect square trinomials, right? You can get the correct answer using the box method, but it's just a longer process. If we know what our perfect squares are, it makes it very quick, very easy. So for example, let's say they want us to factor 16x squared minus, let's do our 169. Okay, and the book says factor. So the first thing we want to check is, are both of our coefficients perfect squares? Well, 16, the square root of 16 is 4, so 16 is a perfect square. This has really resulted into 4x, quantity squared. And then 169 as a negative, we double check, think to ourselves, well, 169 seems like a perfect square. Think we're good. 169 square rooted is 13. Okay? The only way we are able to get our middle term to be 0 is to subtract an equivalent term. So this is where the difference of squares are. Here's our A, here's our B, but it's going to factor out to be 4x plus 13 times 4x minus 13. Okay, and if we FOIL those to double check ourselves, 4x times 4x is 16x squared. 4x times a negative 13 is a negative 52x. 13 times positive 4x is a positive 52x. And 13 times a negative 13 is a negative 169. When we combine like terms, our negative 52x and our positive 52x are going to cancel out to be equals 0x. So we would have 16x squared plus 0x minus 169, and I'm just writing the 0x to emphasize a point. Understand that that's redundant information because anything times 0 would be just 0, so we could omit that. And we'd be left with 16x squared minus 169. So our answer would be presented here. Okay, and it's factored 4. All right. So like I said, when it comes to perfect square trinomials, it's making sure your value for A and your value for C are perfect squares, and then making sure that the middle term matches up to 2 times A times B. Okay, as it's presented in the book.